Hello everyone. In this video, I will explain how to use Microsoft Excel's solver to optimize bundle pricing. This is the same data we have used in the class. There are two concerts, Taylor Swift and Rolling Stones, and 4 segments. First, we're going to calculate the willingness to pay for the bundle by summing the two willingness to pay together. In order to find out which bundle or components consumers are going to choose, we will first calculate the surplus of the 4 segments on the 2 components and the concert bundle. Then we'll figure out the maximum surplus, so which one gives the consumer the highest surplus. So once we figure out the highest surplus, we can then decide which one would the consumers buy. Would they buy Taylor Swift, Rolling Stone, or both concerts? Finally, based on their purchase choices, we can calculate the revenue from each segment. For preparation, I'm going to put the optimal prices in cells F2 through H2. We don't know the actual prices, so I will just put in some random numbers, $10, $10, and $20. And then I will also give each one of these 3 offerings a bundle index. So for Taylor Swift concert, it's 1, Rolling Stones is 2, the bundle, 2 of them together, is 3. That's the prep work for the data analysis. And then I can calculate the total revenue based on the revenue generated from each one of the segments. First, let's calculate the surplus of each segment for each offering. So for Taylor Swift teenager segment, we have B4 minus F2. Here we need to log the row in row 2 so that the formula can be copied in the whole area without having to re-edit the formula. Check the last one. It's correct. Now, the next step is to calculate the maximum surplus for each segment on the 3 pricing components. Copy the formula down. And then, based on the maximum surplus, we can decide whether each segment has bought which one of the bundling component. So here we use the command match, finding the maximum surplus out of the 3 surpluses. And the last 0 specifies exact match. There is a small question though. Here, the maximum surplus can be negative, so we need to add an if condition. If the maximum surplus is negative, then consumers would buy nothing. It's 0. Otherwise, it goes to the match. So now copy the formula down. And then finally, we calculate the revenue we can receive from each one of the segments based on the product that they have bought. Again, we use a if condition here in case the segment has chosen nothing. If J4 is equal to 0, which means none chosen, then the revenue would be 0. Otherwise, the revenue goes to the price of that component. Here we use the command Hlookup. What we're looking for is 1, 2, or 3. Which one of the component is bought? So we look for J4 in area from F1 to H2. And we need to lock both rows and columns, and comma, and then we will find the second row, so 2, and then return. So this is the revenue based on the consumer choices. In this case, everybody has chosen the bundle, so it's $20 for each segment. We calculate the total revenue generated from all the 4 segments that equals to sum of all the 4 revenue components. However, wait a minute. There is a small problem here. This calculation does not force the individual components to have a lower price than the bundle. So the bundle price may or may not be larger than individual component price, but we need that to be true. So here you can add constraints to solver, but instead we're going to use a penalty method. We're going to conduct a series of comparisons and calculate the difference, and then we can decide how much penalty we'll put on the total profit. The first comparison is between Taylor Swift and the bundle. So Taylor Swift minus the bundle. The second comparison is between Rolling Stones and the bundle. And then we'll calculate the total. The first difference is equal to the price of Taylor Swift in cell F2 minus the bundle in H2. The second comparison is between the price of Rolling Stones G2 minus, again, H2. So the way we enforce penalty is if this difference is larger than 0, which means the individual component price is actually higher than the bundle price, then we will use that difference as the penalty. Otherwise, it's 0 for both of them. And the total penalty is the sum of these 2 penalties. So next, we'll put this penalty into the total revenue or profit formula. So what we do is we deduct an arbitrary large number, in this case 500, times the penalty. If the penalty is positive, there will be a big drop in profit. So when solver tries to maximize the profit, it will try to avoid having any positive penalty. It will try to keep penalty as 0. Now we solve this problem using solver. Go to data, solver, and specify the value to maximize. That's the total profit by setting the prices. And there are 3 constraints that we want to set. One is the price for Taylor Swift concert should not be higher than the highest willingness to pay across the 4 segments. So that price should be lower than 90. The second constraint is Rolling Stone concert should also be lower than the maximum willingness to pay over the 4 segments. That's again 90. And finally, the bundle price should be lower than the highest willingness to pay for the bundle across the 4 segments. That's 130. Now we have the constraints. The next step is to specify the solver. Out of the 3 solvers provided by Excel, we're going to choose Evolutionary Solver, and then we check the options to make sure everything is correct. Now everything's fine, so we click OK, and then we start. Now the solver will start running and optimizing the problem to find the best bundle pricing in order to maximize the total revenue. The optimization is done. The answer is 440, the same as what we have done manually. That's our introduction to how to use Excel to optimize bundle pricing. Thank you. We'll see you next time.